Welcome everyone to this webinar in the Iliad Hackathon webinar series. Today we are going to learn about a new software from raw data to design-ready information, co-creating data value chains using the Ramani Toolbox. With me today, I have two representatives from Ramani. I will introduce them in more detail later. My name is Bente Liljaby. I'm going to be your host, as usual, and we have a bit of a simple program today, but I want you to remember to write questions and comment in the chat, and we will have an opportunity to ask questions and also we have a Q&A at the end of this webinar. But today is quite focused on this Ramani tool, and we will get rather detailed information about it. I will start to share the program for you like this. So it's very simple. We start with also a bit of an introduction to Iliad for those of you who are not quite familiar with Iliad and digital twins. Then an introduction to the Ramani Toolbox and by Valentine, and then examples from Furman, both of them from Ramani. Now, just a quick reminder of digital twins. It's a virtual representation of the real world. In this case, we are talking about the ocean. It tells us, gives us a good overview of what now, what next, and what if. Not only that, but it also includes information about what happens in the past. And in addition to ocean-related information, it's also possible to integrate, or we are integrating other information such as statistics and economics, etc. So that's the very quick overview of what the digital twin of the ocean is. In Iliad, we are building multiple twins. And we are doing it through this in the Iliad in the seashell. Is shortly, we are enabling then an ecosystem of interoperable digital twins, and we are connecting then existing ocean resources with new resources from sensors and from citizen science. All of this, the digital twins and its components are being then offered or findable through our Iliad marketplace, where it's not only open for Iliad resources, but also from other participants or members of the entire ecosystem. Iliad is covering, by the way, the European waters, but also Africa and the Middle East, and we are very much interacting with the rest of the world. We provide solutions to various challenges, so societal challenges. Important for us is to be interoperable, and I think that today we will learn about one of the tools that can facilitate this interoperability, at least the transition from one set of data and information to more interoperable results. As I said, we are having several twins, thematic twins and local twins, and we are covering a lot of different areas, ranging from aquaculture to insurance to fisheries, renewable energy, oil spill, etc. You see, we have divided it into 12 different thematic areas, and we are currently developing in more detail 22 pilots or twins, and we are also considering others. So here is a quick overview, and I think this is relevant for today, Valentine, because you see here the data sources on the left side. It needs some preparation, the transformation you will talk about later, some transformation so that we can harmonize it and use it in an operational fashion, so run algorithms, etc., using different types of data. Then we are also using modeling facilities, and eventually a visualization or a presentation of the results in such a fashion that the end users can understand it and integrate it in their decision processes. we are the twins that is following the same logical structure so that we can be interoperable, and reusability is key to our approach. It is a EU-funded project. It's a Green Deal project. It's rather big, or close to 20 million euros in total, with the contributions from the partners, in addition to, of course, the major contributor is the European Union. We are around 56 partners, more or less, and we are in the last year of the project now. So a little bit more about me, then I'm the host. I'm one of the partners in Iliad, of course. I have the title of being innovation manager, but I'm running a lot of the engagement activities and also some of the interoperability, working on the interoperability of data. I have a company, a research and consultancy, working on data management over many, many years. But now, the main character of Valentine today is Valentine Venus from Ramani. He is a geo entrepreneur and a spatial scientist with a broad experience in the exploitation of geo information. And I'm sure we are going to benefit from that and learning more in exactly what that entails in detail. I think we can start there, Valentine. These slides with more of this information about each of the speakers will, of course, be made available for you. And we are recording it, and the other presentations will also be available. Valentine, the floor is yours.
Thank you very much for the introduction, Bente, and the opportunity to present at these webinar series. And thank you very much for helping to organize the Iliad hackathon, and your colleagues such as Tom and others. Yeah, so as Bente was saying, today's topic will be discussing the point of how do you do quick prototyping, taking raw data to decision-ready information, and how do you bring that decision-ready information to where the decisions are made. Be it a fisherman on an estuary trying to grow a mussel, or be it a private individual sourcing or trying to source fish from local markets, and how do you bring all of the wealth and throes of data sets and analysis-ready data to where people are, and how do you do that together? So more about that now. So our background, very shortly, we do ideation and international competition events as our main activity, both thematic and technical support, various framework contracts, both with the European Space Agency and the Copernicus hackathon program. We technically make it, therefore, one of our priorities to help discover data, to make these competition events, which are typically short, as this hackathon is also not very short, but still only a couple of, say, weeks of work for you to translate your ideas into working prototypes. So it is also therefore our focus on how do we avoid confusion as we talk with each other across disciplines, across different backgrounds. You want to align your vocabulary, and it also helps ontology based software development. It also helps for technical people to be able to dig in and not have too much overhead or email communications. So then finally, how do you bring this decision-ready information to where the decision maker is? And we will have a look at some of our OGC compliant APIs to build native Android and iOS applications. And yeah, let me also start by acknowledging all the other partners in the Iliad project that have helped develop some of these tools and make them better, but not in the least place Firman Wayudi, who is the co-founder of Ramani, who has done a lot of work in the background to make this all work seamlessly. So we have some 650 participants that we coached, with more than 85 apps developed. And here's a typical outline of what we do. And if you want to know more, there's a link to an example of our ideathons and hackathons below, linked as a YouTube video. So how do you make this work? We've got the Earth science information communities, such as the oceanographers, the atmospheric scientists, and then you've got the GIS, the geospatial information community, and they talk different data models and different standards, as you see here from the different pillars. So that's where our primary focus has tried to bring these two worlds together. So here you see an outline of our toolbox, where you can query for a given location, a polygon in an area, different raster-based or gridded-based data sets, and get aggregated results or raw data back. I will show you a few examples of this in a minute. Yeah, data discovery talked about making that process easier. So Firman will give a short demo of what we have to offer in that direction. So you can search data, free open text, or data by source, data by institution, and whatnot. But we'll dig into that later. Now, the workflow then that follows once you've identified meaningful data sources. Here's an example of an anomaly detection of ocean productivity over the Western European oceans and the Mediterranean. And here you see that we are tapping into a remote data source, ocean biochemistry, and chlorophyll A as a variable, and then we pull together both these data sources and algorithms, in this case, a yearly anomaly function, to reveal highly or very low productive ocean regions as a way of bringing details to the surface. For example, the sardine run every year is taking place in these areas highlighted in red, where there is enormously high chlorophyll A concentration during typical months of the year. Now, we will also look in some of the examples that Firman will show in a minute at how do you build these workflows together to take the raw data and then in the end publish it to a smartphone application. And particularly in the context of Iliad, digital twinning. Bente already highlighted it in her opening slides, where she mentioned the what if as a key feature of a digital twin. So we will also show you how do you make digital twinning a reality in your workflows by introducing the concept of making decisions under certain conditions. So what if expects a threshold to make a choice at the end of your calculations, either plant a offshore wind park here or 5 kilometers eastward. This has consequences for fishermen. This might have operational consequences if you do your site selection of an offshore wind park differently. And therefore, it's key to understand the error propagation in your added value data pipelines, so that you can be honest about the uncertainty in the input data and how that uncertainty propagates and echoes through into your scenario analysis at the end of the digital twin run. Here's an example of that workflow that includes, thanks to Georgios, who provided us with an example of how to calculate energy from waves, how one could potentially use wave power as a source of green or blue energy in this case. And then you see your typical stack-based workflow on the left with your traditional R&D annotated Jupyter notebooks. And then instead of just one result, you see a range of uncertainties surrounding your predicted value, which might influence your decisions to try and start a sustainable energy plant at this particular location in the Mediterranean. Now we will show you a tool that allows you to turn your stack-based R&D Jupyter notebook into this workflow so that you can trigger it again and again, or deploy it on a different runtime provider, or your own internal self-hosted compute infrastructure, or be able to take this workflow and instead of visualizing the outputs here in the chart, export and publish to a native Android or iOS application. So more about those examples in a minute when Firman takes over. So finally, how do you bring this decision-ready information to the end user? You here see the various API methods that we've jointly developed based on the OGC blueprints. There is a Maps API ontology here linked below in this slide so that you can discover, hey, I'm interested in a web-based application, or I'm interested in an Android application, so that you see immediately where the methods are that you would like to include. Firman will also show you a low-code wizard that will give you snippets of iOS code or snippets of Android code to try and make this work for your situation. Now, we talked about different sources of data, so more about that in a minute. But we also, and combining them in a workflow, but also we talked about the notion of agreeing on a common vocabulary. So for this, we also, under the Iliad project, developed what is called SemFlow, and basically helping you to map your mind on steroids. So it's a tool to organize vocabularies with different semantic concepts using a visual canvas.
Excuse me, can you put them in the presentation mode? It's very hard to read.
Yeah, sure. Thank you. Now, why this emphasis on thematic knowledge? Well, here you see the importance of sort of talking the same language. I think is here illustrated. Here you introduce concepts from artificial intelligence using a living textbook, and then immediately any text you write or end up using in your communications is linked to the vocabularies that you might want to use in your software development or in your database schema. Now, we also included large language modeling to make it easier to extract a knowledge graph from an existing PDF document. So if you find some information, various input documents of your body of knowledge on the internet, then we will guide you through the process of turning that into this knowledge graph so that you can reuse it and align it, for example, to the ocean information model. We've also included the ocean information model and the marine top-level ontology, marine TLO, so that you are able to ask questions from experts in the same language that the rest of the world uses in their communications. but also, as I mentioned earlier, to make sure that you're getting least amount of communication overhead in instructing different team members. One might focus on the spatial data side of things. One might focus on the Android app development. There is need for a common language, as I mentioned earlier. So this is all summarized in a broader presentation from another workshop within Iliad, and I can include the link to this in a minute, or in an email that will follow from Bente. So there is a guided step-by-step interface explanation, as I am showing you here. And there's also an option for you to learn how to align your data classes to of your own data model to the ocean information model in particular. And I will give you an example in the recording. So here you see also Seaport has weather conditions, but it also has water conditions that might come from an observation. And that's actually a class from the ocean information model that we pulled in here. And that observation is coming from a sensor. So this brings us to the support we're offering as part of this hackathon as well. We will be running a help desk in case you choose the tools that we make available and you run into issues or you want to know more. We'll be there to guide you in a ticket-based system. That brings me to the demo of my part of my presentation. So, Firman, if I
remember to have it in presentation mode, Valentine.
Yeah. So Firman is going to share his screen now, so I'll stop sharing mine.
Oh, okay. I thought you were going to show. Yeah.
So Firman is going to show exactly this element of starting with your existing Jupyter Notebook R&D work as a basis and taking that further in turning that into a visual workflow that you can then trigger to get more results or automatic updates if the source of the data changes or the decision maker in the field needs an update. Then that workflow can be triggered, fetching new data from the source, and obviously rerunning the digital twin so you get an updated information in your Android or iOS application. So Firman, go ahead.
Yeah, so Firman, hello, Firman. It was a last minute. So before I give the floor to you, Firman, I will ask you, by the way, to also introduce yourself. But before all that, I want to present Paul, because I asked while you were speaking, Valentine, if people here need to transform raw data to decision-ready information. And you see here the, well, you don't see it. I will share the results so you can see it. Yes, often. And yes, and I want to learn. So this is a very positive crew here, the audience you have. They are either familiar with this or they need to do this transformation from raw data to decision-ready information. So yeah, I thought this was good to do this testing. Thank you for participating, by the way. So now, Firman, to you. Can you introduce yourself a little bit first, and then we are ready to see the demo.
Okay, thank you, Bente. And thank you, Valentine. Hello, all. My name is Firman. I've been working with Valentine for several years. And mostly I'm working on technical aspect, like doing some stack and full stack programmer. So my background is really programming. So okay, I will start to share my screen and then try to explain how we what tools we have been built. Yeah. Okay, can you see my screen right now?
We see your screen.
Okay.
Yes.
So wait a minute.
Meanwhile, if you have questions, please do write them in the chat. And I also provided some information about the hackathon as a reminder for those of you who are new to this. Now it seems to be up and running for you, Furman.
Okay, thank you. Okay, like Valentin has been explained about how we build the tools to facilitate how people can bring the raw data into the public or ready service. Basically, we use the Jupyter Lab for our infrastructure or environment because it's very familiar for other people to use. And then it's mostly use Python, but because Jupyter Lab also support for polyglot, so you can use other language as well, like R or JavaScript as well, or Java. And then this is the interface that we have when you have Jupyter Lab, and then we have two perspective view. One is the Jupyter Lab itself, and the other is the FlowCell. We call it FlowCell. So whatever you made a change on Jupyter Lab, it will appear on the visual workflow as well. So for example, here we have a wave power calculation that Valentin has been shown on the presentation. We can transfer it or convert it to the flow. This is the flow that we created. And then for this to work, you can just need to run the FlowCell will run as well as normal Jupyter Lab. And then because normally on for developer in Jupyter Lab, you have perhaps cell that maybe not need for production or it's only for debugging. You can skip that cell on the workflow or on the FlowCell as well. So yeah, so this is ready for production for so you can consume your data in the other service. Like we also support for RESTful API. So if you need the data in the on the OpenDAP protocol is also support. And then this is the FlowCell, and then we also have what is called data discovery. Okay, data discovery is what you can use to discover the data that you need, and then we also already implement Copernicus Marine Service, so you can discover all data from Copernicus Marine Service and then use it in your Jupyter Lab environment. Okay. I have the other one. So this is for example that we have if you want to explore about the global analysis forecast for some area, so you can just select the product from Copernicus Marine Service, and then if you want to explore or see some data in the map tiles, you can do it as well, and then you can also get the data. And the other things that we also support is the first version of the FlowCell. So we developed what is called FlowCell Builder, where you can create some flow stack to discover and then also expose your data, and then you can also possible to make some added value on your data as well. So for example, here we have a FlowCell for Copernicus Marine. This is very simple and then very easy to use. First, you just need to add the data filter cell. So this is where you can select the date range and then also the bounding box. And then this cell we call Copernicus Marine, where you can also explore about the Copernicus Marine service, like a product ID and the dataset ID as well. So after that, we can publish our data using the OpenDAP protocol here. Once you publish your data, you can consume your data in the other environment, like we have here in the map view. This is the data that we collect, and then if you like to get information about the like a gate point or etc., you can do as well. Hello?
We still hear and see
Ah,
you.
okay.
Yeah.
Because I think I'm alone here. Okay, thank you. So wait a minute. I need to refresh this. Yeah, we okay. Oh, well, okay.
Fear, shall I try to demo it? Because maybe,
Yeah,
okay.
maybe it's broken. Yes, yeah.
What was the username you used?
You can use your instance.
All right, so basically we have like 5 different.
Yeah, just open your Jupyter Lab instance. Then you can
Down.
This is Murphy's Law happening here, I think.
Yeah, there's an error with the service.
The normal will live demo. This is a regular part of the demos.
We tested it this afternoon, but
I know. Yeah.
let me see. We can kind of do it like this. Yeah, so basically, we have a recording of this demo, so I'll just play it now. Can you see this screen properly now?
We see the screen, but we don't hear anything. If it's supposed to hear anything,
That's
we
okay.
don't.
No.
Okay.
So this is going through the same process Wim was trying to explain. So we're pulling in data from Copernicus Marine Services in this case, and zooming to an AOI that you're interested in. So in this case, we're retrieving, I think, temperature or chlorophyll. Physical ocean conditions. So that's like a wave product or something else. And getting the east and the U and V component of the same. So now that we've got our data sets of interest, we can publish that using the DAP data access protocol publisher.
Yeah, this step is what we call dataset DAP publisher, where you can publish the dataset that you discovered before into our Ramani Cloud services. So then you can access it to in the other environment, like in the mobile phone or etc. So basically, you can access the RESTful API on it. So here is the same demo as before that I saw. This demo is only so that from raw data into the publisher, but you can also do some added value in your data, like I saw in the Jupyter notebook before, that you can do some calculation or bend calculation to get uncertainty or
yeah. So now you see the code snippet of your endpoint with the either RESTful URL or the Android code for integrating this data layer in your native Android or iOS application. Veer, could you show us the example of building the FlowCell workflow on your end? Or not?
Maybe when you are changing screen sharing now, because this is still your Valentine, right?
Yeah,
You
correct.
are sharing your screen.
yeah.
So maybe there are some questions. There's a lot of information here. So maybe if there are some questions that is burning,
Yeah, sure.
feel free to, you can raise your hand or write in the chat. So I don't see any. But so you built this, so I can ask one question. So when you were saying that you were retrieving data from the Copernicus services, you were retrieving it to locally to your phone, either so this was created to facilitate using Copernicus data on your iPhone or your Android phone, right?
Correct.
Yeah.
Yeah.
And then you are just I mean, how much some of the data is close to real time, or what's the amount of data that at any point of time that you put on your phone, depending, and wait until you download more data, if you know what I mean.
Yeah. So what we do is in the case of, for example, the Iliad pilot. Sorry. Anyhow, I will go back to this one. Depending on how much data is made available from the sensor. So it's combining space sensors, for example, data from Sentinel-2 or Landsat, and it's combining it from IoT sensors, and of course, human observations. So that really determines sort of the frequency of your observations, if you like, Bente. And on the side of the Android, we are actually caching the data so that after you might lose an internet connection, You will still have the last outputs of the digital twin run. Obviously, hopefully that includes a forecast so that you might actually see the, what's it called? You might actually see the forecasted ocean conditions for the relevant hours that you are actually on the ocean. Yeah. Yeah.
Okay, so it's the caching, and then there's you can determine yourself for how long you are caching.
So the caching is by default, it's taking the full forecast period that you run your digital twin for. It will cache all the time steps contained in the data set, so that you can retrieve, say, information relevant for the moment you are requesting data for. So that's the current hour, obviously, for which you're interested. Yeah.
Okay.
So if you, we have a series of documentations available so that if you want to do either motion sensing, for example, to estimate the physical ocean conditions based on the built-in gyroscope and magnometer and accelerometer built into the phone. There's the motion functionality, or routing if you want to do shortest route or least expensive route from A to B. Crowdsourcing, we have brochures and documentation as to how do you set up two-way communications between your end users and your own application. For example, in the Lemon application, we have built in this feature of allowing people to contribute their observations of invasive species in shellfish farms in the Netherlands and in South Africa. Yeah.
So you can use this as an app for citizen science, but it sounds like you can use it, build also mobile solutions for basically any sensors, IoT, that you might have.
Yeah, because the workflow builder is based on IBM Node-RED, and Node-RED is one of the most popular IoT development environments to access through different protocols, sensor data, and bring them into the workflow, or to trigger the workflow to run again. So say you've got a new buoy sensor observation, then the trigger could be fetch the latest CMEMS equivalent of what my sensor is trying to capture, and get the gridded data from Copernicus Core Marine Services so that I can integrate the two and do another prediction. Yeah. So in this case, you see the water surface conditions at different oyster farms in the Netherlands. For this particular area, there's the threat of herpes viruses when temperatures get too high. Oysters since 5 years or so now are prevalently suffering from what we call herpes virus. And farmers really would like to know this to leave their oyster beds at rest without turning or sorting the oysters by size for harvesting, because any additional stress causes many of the oysters to die in these riskful situations. And so that's where we have used the Landsat 8 and Landsat 9 thermal observations, because there's not a single buoy in this whole estuary. So we were fully reliant on satellite observations. And here you see a way of classifying. On the left, we see current data. And on the right, we have sort of stratified this current data in a simple green, red, orange traffic light color scheme in a way using the same logic, but then in a map view to alert the average normal public user of riskful ocean conditions. Yeah.
Yeah, so Furman, have you found what you wanted to share, or that Valentine asked you to share?
Yeah, thank you. I think I have what I want to share right now.
Oh, okay, but Sadra, you raised your hand. Is this related to what we were just discussing now, Sadra?
Yes, I have a small question from Valentine. Thank you very much for informative presentation. I have just one question. All the discussion was discovering some data, following some workflow, and representing through an official tools that is capable to be run on iOS and mobile application. And you mentioned some crowdsourcing analysis possible embedded in the application. I have one question. Is this tools capable to collect the data from user side as well? To clarify it a little bit, for instance, using these tools as a policymaker to observe some scenarios, is there any possibility to collect end users' data in the crowdsourcing section in a way? I would really appreciate if you
Yeah.
expand on that.
Yeah. So yeah, the tools that we've made available for, I can share my screen again then. For citizen science engagement is basically the following. So if you go to our website and you go to, and it's also listed on the Copernicus website's marketplace. So if you don't find this link here, you can find it on the Iliad marketplace. But if you go to Ramani Cloud, you will find also team management functions. So this allows you to share data on a map with other users. If you want to learn more about, as a developer, about this functionality, there's the documentation where we highlight also the team functions. And basically within each map layer, we are allowing you to set up users that have different roles in a workflow of author, reviewer, and publisher. So any map layer, like the invasive species of shellfish in the estuary that I just showed you, where we have point observations with a photo, you can specify different roles for each user. Some users, like Lily, has all rights. Michael only has read-only rights, and Julie has read and write permissions. And so we do track changes on each vector-based layer with various endpoints that you can even open in QGIS to try and see yourself in different, either in a web-based or an Android application or a rich desktop application, what changes are happening. So there's this feature on this side, and here you see it actually in action with different vectors where people have placed questions or comments about whether or not the observations are correct. And external editors like a rich desktop client like QGIS to track these changes over time. We've developed an app for illustrating this ourselves, so you can consult, for example, the app called Cheetah, where we are actually crowdsourcing observations of post-harvest losses in transport, but also have this feature of sharing commodity prices between users and then being able to plot that and visualize that on a map. So feel free to dig up more details. This is the documentation for more functional description, but there is also more technical information available for developers. So I hope this clarifies the question you have.
Thanks a lot. Yes, perfect. Thank you very much.
Welcome. Firman, back to you.
Thank you, Valentine. I think I will share my screen right now. I hope this will work. Okay, this is what you have been asked, Valentine. So this is the dual perspective of the notebook. Like I said before, you can convert from a normal Jupyter notebook like this into the FlowCell perspective. So basically, you just need to first, let me see. Okay, here you can add this cell as well to the Jupyter notebook, to the FlowCell by clicking the FlowCell icon here, and then you can create a connection in between the cell. So for example, this is the debug cell that you can skip, and then you can continue to the next important cell. Like here, we have a download SIMS data, and then you can also add as well. And then, yeah. Go next.
So whilst you are demoing this, Firman, this is actually one of our Iliad pilots. This is the fishery pilot from Clyde and colleagues from Silvo in Belgium, who are modeling the catching of sole based on collaborating vessels. And they actually asked us to help them with their artificial intelligence workflow to go beyond the random forest and use some deep learning approaches. So here you see their stack-based workflow on the left that we ported from R to the Python language. And now we have a Python version of their basic version that just uses shallow machine learning techniques such as a random forest classifier. And we're now able to turn this into a workflow and include, say, more advanced deep learning approaches from utilizing, for example, the PyTorch package or the other machine learning tools that Firman will show you in a minute. So here you see all the machine learning tools that we've made available at the bottom, and we will add some PyTorch Lightning examples for time series analysis, because we believe that this particular pilot may benefit a lot from time series deep learning approaches, given the time series nature of their sensor data and other geospatial data. So whilst Firman is sort of taking only the critical cells into the workflow perspective, after this, we can easily add the publish to Android or publish to iOS, or export to CWL, so that we can register the output of this user-defined analytics workflow on the Iliad application package registry that Marco and colleagues from Instack have developed. So this is another way of sharing this workflow. Instead of triggering or publishing to Android, you can also store the final workflow in a CWL, as you see here. So this whole thing is now converted to a command line tool of CWL, which allows you to publish this on the application registry of the Iliad marketplace.
Which, for those of you who are not familiar with that language, the application packaging is actually one of the technologies that enable reusability across different digital twins, both thematic and local, depending, of course, on the usage. Not everything is relevant, but the application packaging is one of the technologies we're using for reusability. And here this is linked to what you are doing here then in the Ramani Toolbox is part of helping with that, right?
Yeah, in task 5.4 in the different tasks of the Iliad project, we also facilitate people with an R&D focus on Python programming through a Jupyter Lab interface like this to join the bandwagon of the application registry service, so that you don't need to be a hardcore Fortran or a C++ programmer or a Docker expert. Be able to publish your R&D sciences data processing stack on the same registry.
Yeah, so there's a lot of details here. And am I correct that you have collected on the Ramani page that you have shared, you find guidelines and how-tos for different parts of this pipeline, Valentine?
Correct. Yeah,
Yeah.
and there's also the help desk facility. So if people run into a brick wall while trying to use these tools, there is also a way of reaching out to us through there.
Yeah, it's so immediately I see, well, I saw that Magdalena, you are still here. We were in this in the aquaculture risk metrics for insurance. We were actually discussing how to combine CMEMS data with the local data that we have.
Right.
And perhaps this tool can be used then by hackers, participants in the hackathon, to actually just set up the pipeline and integrate it with the rest of the pilot.
Right. Yes.
Yeah.
Yeah. Definitely.
So how much, in terms of skills required to be able to use this toolbox, could you give a short estimate of the level?
Yeah, I think you need to be positioned in a team with someone with a background in Python programming, I guess, for the core functionality and the algebraic data processing or machine learning processing that you would like to do. It could be very minimalistic, like the wave power is just a one-line algebraic statement that we got from Georgios. So it doesn't have to be rocket science to add value to the raw data. And in terms of the Android or iOS app development, we do provide you with snippets of code that help you consume the particular layer, but you need someone who likes to develop Android or iOS. If you don't have anyone on your team and the app needs to be there because you want to engage with citizens, for example, we're also happy to throw in some Android development support from our side. So maximum 8 hours or so per app. Yeah.
Okay. Okay. You have made an estimate of how much. Okay, I see. Yeah. Any other questions from the audience here? This is you've heard my questions. I mean, they are all over the place. So please ask questions. Any question is good.
Will the tool be available in the marketplace? How can someone utilize it outside of Iliad?
Yeah, it is available on the marketplace of Iliad already. In fact, I just looked it up, and for some reason, things were submitted to the Iliad marketplace a long time ago, but they were still under review button. I don't know why that was. So I will sort that out with Simon so that some of the tools that were contributed are actually visible to the public audience. But outside Iliad, yes, we are running this platform, hopefully for many years to come, God willing, with the international competition events we hope to support. And by the way, you can also, like I showed you just now, leave our platform completely aside and then just download the Python code that you end up developing and take it to another platform as you see fit. Yeah.
Thank you very much.
Welcome.
Thank you.
Thank you, Firman and Bente, for, I'm not trying to wrap it up too early, but if there are no more questions, anyone else?
It's as it seems to have been very clear. But anyways, they can go. You have pointed to, and I did provide the link to the marketplace. And if they search for Ramani in the marketplace, they will find you, I guess.
Yeah.
So and that goes. The links goes further to your webpage and to the support and everything. And by the way, perhaps, I don't know, on so next on Monday, we will be going deeper into the stream handler. So Netcompany will provide that
Nice.
Introduction.
Yeah.
And then either on Thursday or Friday, Georgios Solios will also, who is responsible for sensors in Iliad, will talk about sensors. And you know this. You have used some of the examples from Georgios, right?
Yeah.
So maybe we can tie the link there again on either Thursday or Friday, when we will be covering sensors.
Excellent. Very
Yeah.
well. Cool.
So keep
Yeah,
posted. Yeah.
Last not but least, I also want to thank Daniel, who is our AI expert, who helped convert the Silvo fishery, North Sea fishery pilot from R to Python in a very short amount of time. So thanks, Dan, for helping there. And Firman, of course, and Firdaus here on board as well. Daus is our native Android and iOS developer. So feel free to reach out to us and pick our brains or get the 8 hours of free Android development time. Yeah. But please do mention it if you happen to win the hackathon at the end. Yeah.
Well, I assume you will be part of the hackathon in this way,
Sure.
Valentine. Yeah.
Happy to do that. Yeah.
Yeah. Okay. So with that, do stay tuned by following us on social media. And on the webpage, we will post, well, already you can sign up for the webinar on Monday. And you stay tuned and you will find the registration link also for the sensor webinar in the next week.
Cool.
So with that, thank you very much. Thank you so much, Valentine, and thank you, Firman, for giving us this insight. And let's hope that the participant in the hackathon can enjoy using the work that you have been doing.
Yeah.
Thank you for now.
Bye-bye.
Yeah. Thank you.